Hello, I'm Samuel. In this video, I will fix this Dell LCD screen. This screen stopped working and it's from the customer and it starts blinking, and let's go try to repair it. Take apart this LCD screen. It's quite heavy. Okay, as first I think I can connect it into the mains. To connect the mains. Okay. Very strange noises from there. It's like whew, whew, whew. Yes, it isn't. I don't know it is possible to hear it. On the video, this is a like pulsing inductor in power supply. It looks as an issues with capacitors. Something like that, doesn't it? And let's go take the part. Somehow holding on the top and bottom. I guess these two plastics. I don't want to break the plastic frame of the screen, but I have to remove it carefully. Ah, yes, it is going. It's some kind of clicked with plastics, with plastic clips, and it's going out. Yes, there is a. Yes, there is. These two plastic clips is holding the screen inside. It is quite simple. You have to remove it, and it takes the screen out. Yes, it's okay. And just now I remove the back cover, which is quite clean. This one can be put back. And let's go disassemble the button of the screen. 4 screws around it. It's going up just now. Okay, after I think I can disconnect firstly this one, because this one is this backlight. There is a backlight of CCFL tubes connection. And there is, okay, where it is in the middle. Oh, I can make a mark by a marker. Okay, this one is actually not locked by mechanism, which is there. It's just small pressing. I will try to zoom in it and focus maybe. I'll try to focus there. And this one is actually not locked by this way, because there is no mechanism to lock it. It is simply needs to be pulled out carefully. It is recommended to use a tweezer, because these connectors are something like bonded together without glue by only the mechanical press. So this two is out, and these two others have to be. Yes, this one is okay, and this one is also. And just now I have disconnect the board controller. This looks like this, soldered together with this and glued to LCD. This one is not soldered actually. This one is only, yeah, this one is only in. And just now I can remove it. It is something like EME and EMC protection. And well, the glue is off, this one. And remove the disconnecting the connector. Oh yes, it's becoming apart. Now pick it up. Oh yes, there is an LVDS cable to LCD panel or RGB. This one goes out, and just to pick up. Yes, there is a cable which is going into a display. This one. And this cable is connected with the controller box to the LCD panel for data, and just now I have to disconnect. Yes, it's going out. Okay, it's disconnected. And here is PCBs. The display itself is okay. 2x 4 CCFL tubes connections and data cable for this LCD. Here is the labels for interests. And let's go take the part. Firstly, found the main capacitor and check the voltage. Here's the FBD, or here's the full bridge rectifier. I will check the DC voltage on it. Okay, this 13 volts, it is. I'm testing with my finger, but yes, it is safe. And this is one main screw. 1, 2, 3. This one is actually connecting also the ground of the arch pin to the case from the connector. DC jack input. Okay, just now it's soldered somewhere. Yes, there is this plastic thing which is used like a separation between the board and case. I'm separating the distance. Simply press it by pliers, and yes, now the board is going out. And from the board is one connection to the control from the power supply to board. Oh, this one looks like a core junction. There's another 2 screws. And these 2 capacitors are bad. I'd like to zoom it in first. Something like that. Yes, these 2 are off, and I will change it for new ones. Disconnect this. This looks okay. This one is some interesting. Maybe step down regulator. This will be not fit in. But I only have 330 at 435 volts, 2 pieces, and 470 for 63. The 470 for 63 is higher about only a few millimeters. As this heatsink, we can see it there. This one is high as this heatsink, and theoretically goes inside. This one will be choice for me, and I will put another of 330. This one will be properly functional in my opinion, because it's still only about 100 microfarad capacity difference, but I would like to prefer proper values. I found this PCB from my previous experiment of ATX power supply from Cooler Master, and here I am changing some capacitors in the past, and I found this one which is 470 micro at 50 volts, and this one is very good replacement. Already have a high voltage. I'm gonna to desolder it, and after that I will put. Here's a capacitor, and checking the height. The height is absolutely the same as this one. These two is in the same dimensions, and it will be no any issues to put it there, because there is an ability to, and there is a, this one is actually touching to the case. This one will be touched there, and these two capacitors are there, and it will be on this, and it will be placed against to this insulation layer. I would like to check the quality of these spare caps with using my LCRT4 meter. Testing. Yes, 395, it is okay, and ASR is 0.22 ohms, which is very good. And the other one is testing 487, very well, and ASR is 0.02 ohms, which is also very good. Disconnecting the power supply board. Oh, I damaged the connector. Okay, I will use the pliers to put the pin back. Yes, it is just now visible. Okay. Pliers to put this pin back. Just now it's okay. I am remove the dust from the board, and we will go to unsolder these two caps. Is a D854. I am already gonna to check this diode test. These two diodes, anode, cathode, anode. The capacitor charging, it's okay. Capacitor charging, it's okay, and this one is charging the caps, and it's also a voltage drop about 0.33, which is because it is a high frequency Schottky diode. This flat one, and let's go unsolder the caps. Some additional tin, because this one is made from the desolder it by the lead free tin, and it's better to mix it with leaded tin, and this will be after that. It is so much easy to desolder the pads, the tin from the pads, and remove the removing the bad components from the PCB. Here's some adhesive which is holding it in place. Yes, and going out. Simply put on the side. This one is actually in the same height as my new ones for these two pieces of replacement. The other caps, the main cap is already okay from Capxon. This one is from Suscon, I think. I don't know the quality of Suscon caps. This is a label. This is Suscon 470 micro at 35 volts. I will for interest measure the parameters. I have an issue to determine what component it is. Okay, the tester cannot determine the capacitor because I have very strange parameters. It doesn't make sense to test it. This is that. And my new caps is this two one. Firstly, I will clean it the legs from the caps. This black mark is ground, this one is a plus. And here is a minus of the caps, or ground is marked by this way, and the caps is placed by this way. This minus must be pointed into the black position and will be pressed into PCB. It's pressing into PCB. but there is an issue from the plus line. Just now it's inside. Hold it by the finger, rotate the PCB, and just now you can see the legs from the button. There is also the mark for the polarity again on the button of the PCB. There is a small mark of plus, and this is a ground, or in the ground it is also from the loud, because the plus is going from the diode in the rectifier, and after that going is a transformer, one diode, and there is an inductor going into the, I think, into the main connector to the cable. It is going into the PCB, actually into some regulator, and after going into the connectors. Connecting the connector to driving PCB. Then it becomes more challenging to assemble it all together. One of the most big challenges is connecting the VDS cable back. Oh, other side is quite easy. This one is also easy, but just now I'm going to try to put this connector into this hole. I cannot present the. Looks like it is. Oh, it is two-part assembly. This is a flat cable which is connected in this one. I have an idea. I can actually. Yes, I can do that. I can bend the cable into the almost right angle and try to somehow to connect it. So it will be easier. Maybe. Yes, it is. Yes, success connected. One side is in, and the other side. Just now you have to click it. Okay, it is connected. It is. I put it in under the angle, which is not proper way, and it can bend and damage the connector. You have to actually connect it by right way. Somehow by right way. No, this one is impossible to connect. It's possible to connect, but just now it's not impossible to connect. Alright, it's you have to use a screwdriver to press in place. But it goes down, and after that you maybe put in the place or not. Eh? Eh? Nope. How can I connect these two things together? That means this one will be possible to connect it by this way, because this one is hold it by the sticky tape, and this one is also sticked. It is designed by the Dell to be possible mount somehow in this way. I don't know how just now, but it looks it have been designed to be possible to do somehow by this way to assemble together. I hope it doesn't have no pins are all pins in the connectors is okay. It doesn't need to put it straight in the connector. It's usually too easy. The connectors are usually too easy to connect together, but this one is from the Dell. It's easy to connect, I think, but I'm doing it not proper way. I'll try to bend it a little bit more to get into the sharp angle. Oh yes, it is connected. Then now it's connected on the both sides. I will press a little bit with a screwdriver in. Yes, it is connected. Putting the LVDS cables to other side. And I can already connect it. I put a small dark mark before I disassemble it. Small EMF cover. I will come on EMC and EMF because this one is there due to electromagnetic interference from the high voltage cables, and this one is shielding it. Connect the button PCB. This one cable and assembly. This thing will be put into the PCB, put in it, and pull up and going into the holes on the PCB, and now I will align the top. It is aligned. These two screws are from the mains input connector. Okay, I will repair it after the short test. Connecting to the mains. And it sounds so much better. The green light comes on. And the screen, it's working. Auto detect analog input, self test feature check, red, green, blue. It's working. 2 bad capacitors only. But this monitor is, in my opinion, is quite older, and these caps oh, this screw doesn't fit it. It looks like an issue with the thread. It is M4 times 0.5. It doesn't look like it is. I don't know if it is M3 or it looks like M3. Turn it on. Yes, all games on, no issues, and it shows the Dell auto detect, analog input, self-test feature check. It's working. Thanks a lot.